Hi and welcome to Geeks for Geeks. In this video, we would be discussing the problem known as bike racing. And in this problem, we are told that in a bike race with n bikers, and it is given that the speed of each bike is given and the acceleration of each bike is also given. And it is told that when the speed at a particular point exceeds the speed L, then it is considered as a fast biker, and the total speed is the sum of the speed of all the fast bikers. If sum of the speed of all the fast biker is greater than or equal to m kilometers per hour, then a safety alarm would turn on. And we need to find the minimum numbers of hours at which the safety alarm would start. Translating the same in Hindi so that people would understand better. So एक बाइक रेस हो रही है, उसमें n बाइक्स है, ओके, और सारे बाइक के स्पीड हमें दिए गए हैं, एक्सेलरेशन भी हमें दिए गए हैं, ओके. एंड सपोज क्या हो रहा है कि अगर एक बाइक का करंट स्पीड एल या एल से ज्यादा है, सो इट इज कंसिडर्ड एज अ फास्ट बाइक, ओके, फेयर इनफ. एंड जो टोटल स्पीड है वो सारे फास्ट बाइकर का सम है, ओके. एंड सारे बाइकर का सम, जो टोटल स्पीड का जो सम है, वो अगर m या m से ज्यादा होता है तो एक सेफ्टी अलार्म बजे. अब हमें वो मिनिमम टाइम निकालना है जब वो सेफ्टी अलार्म बजे. फेयर है ना? नाउ लेट अस इवैल्यूएट द सैंपल टेस्ट केस. So let us first calculate for bike 1, for bike 2, for bike 3, the speed at each hour. First hour would be 0, next hour would be 1, third hour would be 1, and this would be 3 itself. For hour 0, there would be no acceleration because the acceleration at each hour. So it would be 20. Okay, it would be 20. For bike 2, it would be 50. And for bike 3, it would be again 20. In the next hour, 20 would increase by 20, that is 40. In initial speed plus the acceleration. Then we have 50. 50 plus the acceleration. Initial speed is 50 plus acceleration, that would make it 120. Okay, and then initial speed, that is 20. 20 plus 90, 110 itself. Then initial speed plus acceleration, that is 20, that would make it 60, and this would make it 80. Then we have 120, and we need to keep adding 70. Then we have 190, and then we have 260 itself. Then we have 120, 110. Then we add 90, that is 200. Then we again add 90, that is 290 itself. Fair enough? This is what it is: 0, 1, 2, and 3. Fair enough? Let us go to the 0th hour. No bike is considered as a speed bike, fast bike. Then we go to the next. We have the sum as 120. 120 is less. So next we move on to 190 plus 200. These two are the fast bike. If we add it, that is 390. It is less than 400. So it is not greater than equal to 400. So the safety alarm won't be turned on. If we go at this point, then this is more than, okay, 0, and this is 550, which is much more than 400. That is why the safety alarm would turn on at the third hour. Okay, fair enough. This is how the output of 3 is coming in. So we can see by evaluating the test case that if we can start from 0th and we keep moving, incrementing forward and check for each hour, in the first point where it is true, it would be our answer. So till answer, I can say that. Okay, now let us move forward. See how many n we have. We have 10 to the power 5n. Suppose we need to calculate for each n. So for each n, we need to evaluate the speed of each of the bike, and there are 10 to the power 5 bike. So if we are evaluating 10 to the power 5 bike, and how we are getting the speed? By adding and multiplication. Addition, multiplication, subtraction, these all take constant time. That is why for each of the bike we are doing constant operation, but we need to iterate over the bike. That is why the number of operation is 10 to the power 5 for each check. For each check. For each check. Now L and M, okay, M is equals to 10 to the power 10 itself. So the value 10 to the power 5 multiplied by the answer itself. Suppose 10 to the power 9, 10 to the power 9. It is much greater than 10 to the power 14 than 10 to the power 8. So definitely we would be getting a TLE even before implementing it. Okay, we know this. Okay, मैं फिर से बताता हूँ क्या करूँगा ना कि मुझे पता है कि मैं 0 पे देखूंगा, 1 पे देखूंगा, 2 पे देखूंगा, 3 पे देखूंगा, और ईच पॉइंट पे कैसे देख रहा हूँ कि मैं सारे बाइक का स्पीड ले रहा हूँ, सारे बाइक का स्पीड ले रहा हूँ, जो जो फास्ट बाइक कंसिडर हो रहे हैं उनके स्पीड ऐड कर दे रहा हूँ एक जगह, उनके स्पीड ऐड कर दे रहा हूँ एक जगह. Now we move forward and we do this. So now if we implement this, let us just implement this even if we get an TLA, and then we would think about optimization. Okay, so now let us start the implementation itself. So what we can do is we can have a for loop where int I is equals to 0, I is less than equal to some high value, int I is equals to 2e9 plus 5. Let's take this value. So not int high, let's take everything as long because we need to operate on long, so let's take it down. And this one would also be, okay, and this one would be I and I plus plus. For each I, we need to check. So what we would do is, if we would design a check function, okay, and we would pass this I. So now let us design a check function. Check function would tell that if the alarm would be turned on at this hour or not. So we would just write ck, and then we would have the value of I, okay, or let's have the v value v, and then we have, and this should be long, then we have long n, then we have long m, then we have long n, then we have long h, and then we have long a, etc. Fair enough. Now we have the total sum. So long dot would be equal to 0. Now we would iterate over this. Int I is equals to 0, I is less than n, and I is. Now the current speed. So long current is equals to the value, the initial value, that is the speed of the bike, that is given by hi, plus the current hour. What is the current hour? Value v multiplied by the number of acceleration, that is a of I. So if current is greater than equal to the value of L, so it is considered as a fast bike. If it is considered as a fast bike, then it would contribute to the total speed. Total speed is equals to dot plus current. And then at the end, we would just say that if total is greater than equal to m, then we would return true, else we would return false. Okay, fair enough. This is what we need to do. Okay, fair enough. This is what we need to do. Now we would go back and then we would pass whatever is needed. Then first we have the I thing, then we have the N, then we have the M, then we have the L, then we have the given H, and then we have the A. So if this is true, return I. This is simple enough, but time complexity is absolutely very large. That is 10 2 into 10 to the power 2 into 10 to the power 9 plus 5. Okay, and this would definitely give an TLE. Why? Because it is greater than 10 to the power 8. So whatever be the case, so now we need to move forward and we need to think of something different. So now as we can see that suppose the value is 5, suppose the answer is equals to 5. So if the total speed at 5 is greater than, suppose answer is equals to 5 and m's value is equals to 100. So at 1 the alarm won't be turned on. So I would just write here no. Okay, at 2 the alarm won't be turned on, at 3 the alarm won't be turned on, at 4 the alarm won't be turned on, at 5 the alarm would be turned on, at 6 also, if we go to 6 also, then only the speed would be greater only. What I'm trying to say is अगर 5 पे ही वो speed पार हो जा रहा है तो 6 पे वो speed तो definitely पार होगा. So beyond that also we would be having yes only. So if you observe this, that no, 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 and then yes, 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 and we need to find this yes, then this is a monotonous function. Okay, monotonous function. And now, if it is a monotonous function and we need to find the first position of y or the last position of y or the first position of n or the last position of n, then definitely the question is of binary search itself. Okay, now what we need to do is we need to do binary search. Now let us see the monotonous function and then we would decide. So what we would do is, as we do in the binary search, we would have a low and high. We would have this one would be low and this one would be high. Suppose at some point of time we are at the mid and the mid is a yes. So if mid is equals to yes, that means at this midpoint it is true. Then there are two possibilities. Either it is the first occurrence, or if it is not the first occurrence, then the first occurrence would definitely lie on the left hand side. So if we want to move on the left hand side, then we need to iterate over high is equals to mid minus 1. That is what we would do is we would take up this mid and we would go in here. This is what we are doing. Okay. So if it is y, we would first save it because there are two occurrences that it might be a potential answer. It is a potential answer. And then we would try to find the first occurrence. And as we know that it is a monotonous function, so the first occurrence won't lie in the right hand side. Fair enough. Now the case when mid is equals to no. If mid is equals to no, that suppose this is the mid position and this is not the mid position, then we know that going at the left hand side, we won't encounter any yes. We need to go on the right hand side to encounter a yes. So what we would do is low is equals to mid plus 1. How this is making sense? What we would do is we know that this is checked. So we would just keep the low here and then we would have the search space at that side. So if it is no, we are moving that side. If it is yes, we are moving that side to find the first occurrence. Fair enough. So now we would do the same. So low is equals to 0 and high would remain the same. And instead of this for loop, what we would do is while low is less than equal to high, first we would find the mid value. So long mid is equals to low added to high and divided by 2, and then we would check. Okay, ck mid and then n and then n then m. Okay, and then m and then l and then h and then the particular a itself. If it is true, we were moving on the left hand side. To move on the left hand side, what we are doing is high is equals to mid minus 1. Else, and that can be potential answer, else low is equals to mid plus 1. That is, we are moving on the right hand side. And we need to save the potential answer. So long answer. And here we would save the answer. Answer is equals to mid itself. Now at the end, we will return the answers. Now let us just compile and run and see if we are getting a messy one. We are getting a correct output for the sample test case. Now we would just submit it and see. And yes, we got an AC. Now let us discuss the time complexity of this solution. In this solution, we are doing a binary search. And the time complexity of binary search is log n. At each log n operation, we are iterating over the whole thing. And here we are just doing the comparison and all, if statement and all. And we are just doing addition and all calculations. So constant operation for each element, and we need to iterate over all the elements. So this for loop is doing big O of n task. And for each task, we are doing constant operation. So in total, we have the time complexity of n for each log n operation. So we have the time complexity as n log n. Okay, and 10 to the power 5. So, and this is very much feasible and it would be less than 10 to the power 8. That's it for today. Thank you and have a nice day.